The universe is vast. It teems with billions upon billions of stars. Around many of these stars, planets orbit. We call these planets exoplanets. They are very far away, but we can still learn about them. How? Light holds the key. Light from a star passes through the atmosphere of an orbiting exoplanet. This changes the light's properties. We can analyze these changes using powerful telescopes and instruments. This is called spectroscopy. It allows us to identify the chemicals present in an exoplanet's atmosphere. By studying these atmospheres, we can begin to understand what these distant worlds are like. Are they hot or cold, gaseous or rocky? Could they harbor life? And perhaps, even more intriguing, could they be home to advanced civilizations? Imagine, for a moment, that we find an exoplanet with an atmosphere just like Earth's. This would be an incredible discovery. It wouldn't necessarily mean we've found life, but it would certainly be a good place to start looking. We know that planets are dynamic, ever-changing systems. Geological processes like volcanic eruptions can release huge amounts of gases into the atmosphere. These gases can significantly alter the chemical makeup of an atmosphere. It's like adding a burst of color to a once blank canvas. Life itself can also dramatically change an atmosphere. Think of Earth's early atmosphere. It was transformed by the emergence of photosynthetic organisms. These organisms released oxygen as a byproduct of their metabolism. This eventually led to the oxygen-rich atmosphere we breathe today. So, when we observe the atmosphere of an exoplanet, we need to consider both geological and biological processes. These natural forces can create a wide range of atmospheric compositions. Understanding these natural processes helps us to identify what is normal for a planet's atmosphere. This, in turn, allows us to recognize when something truly unusual is happening. What if we detect something in an exoplanet's atmosphere that cannot be explained by natural processes alone? What if we find evidence of something artificial? Something that could only have been put there by intelligent life? Scientists use the term technosignatures to describe such evidence. Technosignatures are essentially signs of technology. They are like cosmic fingerprints, hinting at the presence of a technologically advanced civilization. These technosignatures could take many forms. They could be pollutants released by industrial processes, similar to what we see on Earth, or they could be signs of large-scale engineering projects like massive structures orbiting the planet. Imagine detecting the unmistakable signature of chlorofluorocarbons, CFCs, in an exoplanet's atmosphere. CFCs are synthetic chemicals that were once widely used on Earth in refrigerators and aerosols. Finding them elsewhere would be a strong indication of technology. Certain chemicals are unlikely to be produced in large quantities by natural processes. These chemicals, if found in an exoplanet's atmosphere, could be strong indicators of technological activity. One example is perfluorocarbons, PFCs. Like CFCs, PFCs are synthetic chemicals. They are extremely long-lived in the atmosphere. Finding them in significant amounts on a distant planet would be a tantalizing clue. Another intriguing possibility is the detection of unusual isotopes. Isotopes are atoms of the same element with different numbers of neutrons. Some isotopes are produced more readily in nuclear reactions, which could be a sign of advanced technology. These are just a few examples. The possibilities are vast, limited only by our imagination and our understanding of chemistry and technology.